So given, so I'll take second example. Given f of x equals x square, just a second. F of x equals x square is given, and in the interval minus pi to pi, minus pi is less than x less than pi, with f of x plus 2 pi equals f of x. So this is a periodic function with period 2 pi in the interval minus pi to pi, and since the interval is defined as minus pi to pi, so I can now test this function, is it even or odd. So here let me check f of minus x, so that means it becomes minus x whole square, so obviously it is an even function. So that is f of x is equal to is f of x. So I can say that given f of x is even function. So when it is even, so in the Fourier series, if it is an even function, obviously it contains only cosine terms. It does not contains any sine terms. So that means I can say that Bn is 0. The coefficient of sine is 0. So therefore the Fourier series expansion for an even function, the Fourier series expansion for an even function or even f of x is, so that is f of x equals a naught by 2 plus summation n from 1 to infinity an cos 2n pi x divided by t, called as equation 1. So where a naught is, so therefore a naught is defined as 2 by t integration from c to c plus t f of x into dx is a naught, and similarly we have an, and that is defined as an is equal to 2 by t integration from c to c plus t f of x into cos 2n pi x divided by t into dx. Okay, so this is, we need to find the terms a naught and an. So to evaluate a naught and an, so what is given? The given thing is f of x is given, and the period is given. Period is 2 pi. So with this I can easily evaluate a naught and an. Okay. So now we'll find a naught. So a naught is 2 by, period is 2 pi, integration c is minus pi, and minus pi plus 2 pi is pi, So that integration from minus pi to pi, f of x is x square into dx. So simple integration of, so 2 cancelled, 1 by pi remains, and integration of x cube, x square is x cube by 3, limits from minus pi to pi. Now, so this is 1 by pi, limits pi 1 by, so 3 is also constant, I can take that 3 outside. So 1 by 3 pi into pi cube minus of minus pi whole cube. Okay, so that is 1 by 3 pi. So pi cube plus pi cube is 2 times pi cube. So minus pi cube is minus pi cube, minus pi whole cube is minus pi cube, and minus into minus plus. So when you add these two, we get 2 times. So this 1 pi cancelled, we get a naught is 1, so 2 pi square by 3. So a naught is 2 pi square by 3. Okay, so this is what a naught. Now, since this function x squared is even, so as you seen that integration from minus a to a, f of x into dx, if this is f of x is even, so this can be written as 2 times integration from 0 to a f of x into dx. So you can use this also. So that is, in other words, so instead of, so here is function is simple, we can easily substitute I'm sorry, you can easily substitute this limits. So let me try another way. So that is r. So since it is even, a naught is, I can directly write 2 by 2 pi integration from minus pi to pi x squared into dx. So this one, so what we can do, since it is x squared is even, instead of considering minus pi to pi, I can consider 2 times 0 to pi. So this 2 cancelled, so this becomes 2 divided by pi integration from 0 to pi x squared into dx. So that is, after integration we get 2 by pi, integration of x squared is x cube by 3, 0 to pi. So here only upper limit, so that becomes 2 divided by 3 pi, upper limit is pi cube. So after simplify we get this also 2 pi square by 3. So this is if you use the properties of even and odd function to evaluate integration. So since it is even, instead of integrating the whole interval, I can take 2 times the half of the interval. So that is also, you can easily do it. Okay, so next we will evaluate an. So therefore an is equal to 2 by period 2 pi integration from minus pi to pi f of x, that is x squared, into cos 2n pi x. Yes.
It's after that 2 by 2 pi, integral of pi minus pi x square dx, after that you have written 2 pi, 2 by pi. How come, sir? It's 1 by pi, right? If 2 gets cancelled, it's...
Yeah. So here this 2 it comes because of the even function. So here if it is a even, minus a to a, f of x dx can be written as 2 times 0 to a. Now you check the lower limit. The lower limit earlier it was minus pi, now reduces to 0 to pi. Okay.
Now asking that you have cancelled 2, right?
Yeah.
In first step. So it would be 1 by pi, right? You have written
Yes.
2.
Yes.
2 by
1. Yeah. Correct. If you cancel, okay, I'll write one more step. It is 1 by pi integration from minus pi to pi f of x dx. This is what I mean, f of x is x square. So this is what actually you will get after the cancel of 2 x square dx. Now you use this property, okay, what I am making star, that is, so what is this property tells, if the integration from minus a to a f of x dx and the f of x is even, if f of x is even, it becomes 2 times 0 to a. Now we are reducing the interval of minus pi to pi to consider only 0 to pi, okay. So that 0 to pi, when you take 0 to pi, this 2 has to take 2 times that the area. Suppose if it is c, this is a quadratic function and it is in minus pi to pi, and you want to find an area bounded this interval, okay. So this is the area, and here this is the area. So since it is a even function, whatever the area in the left side of the origin is same as right side of the origin. So that means this is one part and this is another part. So both parts are the same. So when you find a total area in the interval to minus pi to 5, this is nothing but 2 times any part of the area. So that means either left side of the origin or right side of the origin you can consider. So that too is because of this 0 to pi. We have changed the interval, instead of minus pi to pi, we have considered 0 to pi. This is for only even function. You should not consider same thing for odd function. If it is an odd function, the area becomes 0. Is it clear now?
Yes sir, yes sir. Thank you sir.
So now we come to this second now we need to find an. So an is 2 by period, so that is 2 to get cancelled, and f of x is x square, again 2 pi. So in the cos of 2 pi get cancelled. So what we remains is 1 by pi integration from minus pi to pi x square cos nx into dx. Now again you have to check these functions. So here the x square is even function. X square is even. Cos is also even function. So product of even into even is again even, right? The product of even into even is even function. So total integrand itself is even. This integrand is even now. Since the integrand is even, again I can use the same property what I explained in the interval minus a to a f of x dx. So that means, so this can be written as further, so that is 2 by pi, again I am taking 2 and I will make the lower limit as 0, that is half of the interval I am considering. Integration from 0 to pi x squared cos nx into dx. So now we need to integrate using Leibniz rule. So that is 2 by pi first function x squared, integration of second function is sin nx by n minus derivative of x squared is 2x and integration of sin is minus cos nx divided by n square, and again we have minus alternative plus, so plus and minus alternative here. So derivative of 2x is 2 and integration of cos is minus sin, so minus as it is sin nx divided by n cube, and again minus derivative of 2 is 0, so rest of the terms are 0, limits from 0 to pi. So this is how we can use Leibniz rule. I hope you are clear that. So now in the integrand we have considered first function, second function. So here first function into integration of second function is integration of cos nx is sin nx. So this will be a second function again. Now next is, since it is a plus, next sign is minus, and derivative of first function is again 2x. So this will be a first function in the next one, and integration of this whole thing you have to do. Integration of whole thing, that is whole thing means if it is a we call it as second function. So that will be minus cos nx by n cube. So this whole term now it is considered as a second function. Again plus alternative sign, plus and minus, plus derivative of this 2, derivative of 2x. So it is 2. So this is first, and integration of this whole thing second function, that is previous term, will be integration of cos is sine, and same negative sign comes here and divided by n cube. Now again in this term, this sine nx by minus sin nx by n cube will be second function. Next minus sign, because earlier it is previous term positive, and derivative of this 2, derivative of 2 is 0, so rest of the terms will be 0. So now we need to substitute the upper limit and lower limit. So here, so when you put an upper limit, I'll get sin n pi. So the value of sin n pi is 0, and when you put a lower limit, sin 0. So sin 0 is also 0. So since for both the terms sin n pi is 0, sin 0 is 0, so sin terms obviously 0. Again the last one is also sin n pi is 0 and sin 0 is 0. So first term and last term will be 0. Whereas second term, if you put so you will get a second term only. So that means minus into minus plus 2x by n square cos nx term is the only term remains, and the final last end terms will be 0. So now I'll take one more slide. So now since what is that an is 2 by pi, and this will be 2x into, so this is minus into minus plus cos n pi nx divided by n square, limits from 0 to pi. Only this terms remains. So therefore an is 2 into 2, 4 divided by pi n square. So n square is constant, and when you put a upper limit, you get minus 1 power n. When you put a lower limit is 0, because x is 0. Cos 0 is 1, I agree, whereas x is 0. So this is pi into minus 1 power n. And you put a upper limit. So that becomes 4 into minus 1 power n divided by n square. Pi get cancelled again. 4 by n square into minus 1 power n. So equation 1, finally equation 1 becomes f of x is x square, that is equal to a naught. So what we got, a naught? A naught is pi square, 2 pi square by 3, and a naught is 2 pi square by 3 into 1 by 2, because a naught by 2 is there, plus summation n from 1 to infinity an is 4 by n square into minus 1 power n cos 2n pi x by t. So 2 pi get cancelled, it will remains nx only. So that is the final x square equals 2 cancel, pi square by 3 plus 4 into summation n from 1 to infinity minus 1 power n divided by n square into cos nx is the required Fourier series of x square in the interval minus pi to pi. So any doubt? Have any doubt? You can clarify your doubts. Okay, we got a naught as 2 pi square by 3 and an is 4 by n square into minus 1 power n. Okay, now we take another example, that is f of x is equal to mod x in the interval minus pi to pi. Any doubt in this previous example? If it is not, I'll take one more example. So that is third example. Given f of x is, any doubt? F of x is equal to mod x in the interval minus pi less than x less than pi, and it is f of x plus 2 pi. You know how you get 2 pi? The difference of these endpoints. So let me take this is, say, a less than x less than b, and we are using a Fourier series. You want to find a Fourier series expansion, then period is b minus a. If you take a period, so this is the b minus a, unless if it is not specified. So if it is specified, then that will be the period. So this is pi minus of minus pi will be 2 pi. So this is how we can find a period. Since we are finding a Fourier series expansion, so it should be a periodic function. So now another interesting factor is f of x is the mod x, and again everyone, you can easily say it is an even function. So this is everyone you have, we can easily verify it is even function, no doubt at all. Okay, so since the interval is defined in minus pi to pi, so I can easily tell it is a even function. And further, this f of x we can define as mod x is equal to negative x in the interval minus pi less than x less than 0, and positive x in the interval 0 less than x less than pi. So any half of the interval, if we choose a negative part, that is left side of the origin, you can use minus x, and right side of the origin is plus x. So this is the definition of mod x. Now since it is a even function, the Fourier series expansion for the even function is, it contains the Fourier series expansion for the even function is, so what is that? F of x equals a naught by 2 plus summation n running from 1 to infinity an cos 2n pi x divided by t, is called as equation 1. And the definition of a naught is, therefore a naught is 2 by t integration from c to c plus t f of x dx, and similarly an is 2 by t integration from c to c plus t f of x into cos 2n pi x by t into dt. Sorry, not dt, it is dx. Okay, so this is the definition of Fourier series for an even function. and we have defined that given modulus function, absolute function, as like this. So with this only I can find a Fourier series expansion. So now next we need to find a naught and a n. So that is for a given a naught and a n. So therefore a naught is again 2 by period is 2 pi, integration from minus pi to plus pi f of x into dx. So that is again 2 to cancelled, that is 1 by pi, and f of x is even function, so it is even. So if it is even, I can put 2 times integration from 0 to pi into f of x. So the function that is actually not f of x, what is that f of x is mod x. So mod x into dx. So mod x definition in the interval 0 to pi is plus x. So that is 2 by pi, integration from 0 to pi, the mod x becomes x only into dx. So because we have defined in the interval 0 to pi. So that will be 2 by pi, integration of x is x square by 2, limits from 0 to pi. So again I can cancel this 2. So therefore a naught is 1 by pi, upper limit is pi square, lower limit is 0. So we get a naught as 1 by pi. So a naught is, we get a naught as 1 by pi. So similarly we need to find an, and therefore an is 2 by t. So the 2 by t is the period 2 pi, limits from minus pi to pi, f of x into cos 2n pi x divided by 2 pi into dx. So that is 2 to cancel, 1 by pi, integration from minus pi to pi, f of x is mod x.
Excuse me, sir.
Yes.
So it should be pi. A naught should be pi.
I'm sorry, yeah, I'm sorry. I'm really sorry. Thank you. Yeah.
Welcome, sir.
Yeah. This is pi, not 1 by pi. I'm sorry. So because pi squared by pi, so pi squared by pi cancel, we get pi only. Okay, so now here in this an, so you see mod x is again even function, and cos nx is also even function. So product of the resultant will be, this two product becomes an even again. So therefore it is an even function. So again I can make use of properties of even function to find an integration, and that is 2 times the 2 times, so 0 to 2 times from 0 to pi. So therefore an is 2 divided by pi, integration from 0 to pi, mod x into cos nx into dx. So the value of mod x in the interval 0 to pi is x. So that becomes 2 divided by pi, integration from 0 to pi, x into cos nx into dx. So as usual for Leibniz rule, or you can apply. So that becomes an equals 2 by pi, a first function into integration of cos is sin nx divided by n minus derivative of x is 1 into integration of sin is minus cos nx divided by n into n square, and derivative of 1 is 0, so plus everything is 0, limits from 0 to pi. The same concept what we said earlier, sin n pi is 0. So same results we make use. Sin n pi is again 0 and sin 0 is 0. Both for upper limit and lower limit I can say this is 0. Okay, so now after simplification we get this becomes, so minus into minus, so this minus into minus is plus and n square is constant, I can take it outside, so this becomes 2 divided by pi n square into upper limit cos n pi and minus cos 0. So this becomes cos 0 value is 1 and cos n pi value is minus 1 power n. So therefore n becomes 2 divided by pi n square into minus 1 power n minus 1. So here this is a n. Again if you see the term, so again you can further define that minus 1 power n minus 1. So this is this term. Suppose n is odd. What happens? N is, say, odd number means 1, 3, 5. When n is equal to 1, minus 1 power 1 is minus 1. So minus 1 will be minus 2. So when n is odd, it is minus 2 for odd n. When n is even, say n equal to 2, so minus 1 power minus 1 square is plus 1, plus 1 minus 1 becomes 0. So this is for even n. So this is the terms we get. So finally I can write minus 4 divided by pi n square for n is odd. Okay, so that is also we can notice from this result. So next I can what we need required Fourier series expansion. So for mod x, therefore equation 1 implies mod x equals a naught by 2, that is a naught is pi by 2 plus summation n from 1 to infinity an. So an is 2 divided by pi n square into minus 1 power n minus 1 cos nx. So is the required series, or you can further expand this, we get pi by 2. So as it is n equal to r, n is odd numbers, so we get I can take minus 4 by pi constant it will be, and the series if you expand this summation you get cos x divided by 1 square plus cos 3x divided by 3 square plus cos 5x divided by 5 square. So likewise the terms increases. So this is, if you take first term n equal to 1, so when n equal to 1, mod x equals pi by 2 minus 4 cos x divided by pi. So this is first harmonic, we call it as first harmonic. So this is analysis, this is one type of analysis. So that means mod x, so the actual curve for mod x is, as you know, this is mod x in the interval minus pi to pi, and if you use Fourier series expansion and if you want to plot the graph for n equal to 1, n equal to 3, I mean n equal to 2 is not possible, so n equal to 3, third harmonics, so first harmonic, third harmonic, fifth harmonic, likewise you will get a non-zero terms for this. So as we go on plotting that with this original function mod x, so finally that gives you this result only, I mean for a finite number of n's, that Fourier series approximate this mod x. we'll see this analysis later. In the if you come to the campus, you can demonstrate through MATLAB. So that will how the approximation gives you better results. Okay, this is only what we are expecting. You have to solve this problem to get a solution for mod X like this. Up to this is enough. Okay, so let me take one more example. So here we got same result. Okay, now before going to take a so before going to take the example, I need to define even and odd function for piecewise functions. So like this is even and odd function definition. For piecewise functions. So that is, so suppose the function f of x is defined in this format, say phi1 of x in the interval minus a less than x less than 0, and phi2 of x in the interval 0 less than x less than a. So here x belongs to an interval minus a to a. So we have a origin at the center, and we have same length in the both the sides. So in this case, you want to define, want to check whether it is a even or odd. So simple way is you take the first one, phi1 of x, we have given phi1. So you take in that phi1, you replace x with a negative x. You replace x by negative x, and if that gives you the phi2, when you replace when you replace phi1 x with negative x, and if that gives you phi2, then f of x is even. F of x is even function. F of x is even. Suppose if you take phi1 and replace x with negative x, so phi1 you are replacing x with negative x, and this gives you negative times phi2, negative times phi2 of x, then this becomes f of x is odd. F of x is odd function. I hope you are noting, you are writing the same. So from the phi1, if you replace phi1 with the negative x, and that becomes phi2, the second function, then f of x is even. And if you take, if the same phi1 replace with negative x, that becomes negative times phi2. Negative times phi2, then f of x is odd. So it is same for a function. Now there is another case, that is if it is not defined in the interval minus a to a. Suppose this f of x defined like this. F of x is equal to phi1 of x in the interval 0 less than x less than a, and phi2 of x in the interval a less than x less than b. So here x belongs to 0 comma b, where a is intermediate point. A is intermediate point. Okay, just a point. So that interval 0 to b divided into 2, one is 0 to a, another one is a to b. So in this case, if you want to say that is even or odd, so now First phi1, in phi1 usually the previous case we are replacing with negative x. Now instead of negative x you have to take an end point b minus x. So you have to replace not only just